the world of business. It's about having good ideas, good technology, and good information. It's found on everything that's computerized, from cell phones to ATM machines to monitors in hospitals. Software. It's the driving force behind all of these devices. But creating software to control such complex equipment isn't always easy.
Creating this software is actually very difficult because the processor has to do lots of different things all at once. For example, inside an ATM machine, the processor has to be involved not only with communicating with the bank's database, but also interacting with the user in terms of receiving their key presses and updating the display, and finally dispensing the cash. And all of these things must be done in a timely manner, or else the system won't work.
One of the common elements in the world of software design is what's known as a multitasking kernel. The component is a building block that allows a microcomputer to do many things at once.
The consumer can't see the multitasking kernel directly. Rather, it's a behind-the-scenes tool that's used by the programmers who are creating the product, and they use it to break the software up into individual pieces and deal with those pieces one at a time. And that makes their job easier. And because it makes their job easier, it's cheaper to build the product and also can be developed more quickly. And that ultimately benefits the consumer as well.
Over the past 30 years, the multitasking kernel has evolved from a theoretical concept to a robust piece of software. The technology was first applied to microprocessors by engineers like those at KDAC who had to design programs to run reliably on their own without an operator standing by to hit a reset button if a problem arose.
Programmers who create the multitasking software work diligently to test their software, and they're frequently the first to encounter flaws in the computer chips themselves. Once the chips have been repaired, they're then delivered to developers who incorporate them into these end products in a wide range of industries: aircraft equipment, factory robotics, medical equipment. None of these products can stand failure. They must be reliable.
Although this type of software isn't used by engineers to build every kind of electronic product, some industry experts predict that day isn't far off.
In 2002, there were 6 billion computerized devices created. That's one new device per person on the planet. The software inside some of these devices is still being developed using older technology. But as demand for these devices grows in the future, new technologies will be needed to get the job done.
As we continue to rely on computerization to help get us through the day, ongoing developments are helping to take these tools to the next level, to help us do even more in the years to come.